Good afternoon, good evening, evening. It's the borderline between them. Hi, everyone. I'm really excited to be here today to be speaking with you about how to accelerate your compute workloads with our newest file service, Amazon File Cache. We launched File Cache at the end of September, and it's designed to help you better use AWS for your compute-intensive workloads, regardless of where your data is stored. And actually, let me just go back 1 second. I should introduce myself. I'm Edward Name. I'm the general manager of file storage at AWS. And so that's the Amazon FSx family of services, Amazon EFS, and Amazon File Cache. And I'm joined today by Eric Anderson, who's the GM of File Cache at AWS, and by Brandon Lindauer, who's a senior solutions architect that's focused on the media and entertainment space. And let me start by talking about the cloud journey. And the cloud journey for almost every customer varies, but there are some common themes, and for many customers, there are several phases of cloud adoption. There is bursting to the cloud, and so with lots of compute and storage capacity and existing workflows already on premises, customers know they want to eventually move to the cloud, but they don't want to wait for that full move to happen before taking advantage of cloud capacity and agility. So they want to be able to burst their compute to the cloud. And this is for everything from chip design to media and entertainment workflows like transcoding to genomics analysis. And that's Amazon File Cache that helps support those types of workloads. Then there's moving to the cloud and taking existing apps and existing data that's associated with those apps and moving them as easily as possible without re-architecting or rewriting. You're able to essentially lift and shift and be able to gain all the benefits of the cloud, the agility, the security, the availability, the durability, et cetera. And that's really what Amazon FSx and the family of services with FSx is focused on. And then there's a bunch of workloads that are net new in the cloud. These are modern cloud-native workloads. And think of things like serverless compute, serverless functions, serverless containers, serverless storage, serverless databases, all of those pieces coming together to build modern new applications that are really taking advantage of cloud agility and cloud elasticity. And our Amazon EFS file service is really focused on those types of workloads. So today, of course, we're focused on the first of those, which is Amazon File Cache. And before we get into the details of File Cache, let's take a step back and talk about the problem that customers asked us to solve with File Cache, the reason that we built File Cache. And so what is the typical setup with cloud bursting? Well, you have your primary compute and you have your primary data on premises, and then you spin up compute on AWS. That's kind of like at a very high level. That's what the architecture looks like. So what's the problem with that? Well, your compute cluster on AWS needs to access your data that's on premises. And so in the case of data that's residing in a file system on premises or network-attached storage on premises, which is the most common place that data sits on-prem, your compute on AWS will typically directly mount your on-prem storage. And that creates some challenges for compute-heavy workloads, latency-sensitive workloads, throughput-heavy workloads, because of the potentially high latencies and the limited network bandwidth that you have between AWS and on-prem. So if you think about like the typical direct connection, for example, it's a 10 gigabit per second connection, and you, depending on where you are relative to the region, you might have latencies ranging from 10 to 30 milliseconds. For a bunch of workloads, that's fine, but generally for really compute-heavy workloads, those performance characteristics aren't going to work. And so what have customers historically been doing to address that problem before we had File Cache? Well, they historically did mass copying of data from on-prem to AWS before starting their workload. And so what's the problem with that? Well, there's the complexity of moving large amounts of data. That's just something that can be complex, and the larger the data set, and depending on your directory structure, et cetera, that could be a pretty complicated thing to have to manage. Then there's the time to move it. And you generally can't start your workload until the data is moved over. And just like as a rough kind of back of the envelope, if you take 10 terabytes of data, let's say you have to move 10 terabytes of data over, That could take over 2 hours with a typical 10 gigabit per second direct connection. And then there's the problem of copying more data than you need. Because a lot of times when you're about to start your processing job, you don't actually necessarily know which subset of data that you're going to need for that particular processing run. And so you're going to be potentially copying 5 or 10 times more data because you're copying a large superset of your data rather than the specific files that you necessarily need. And that's why we launched Amazon File Cache. So with File Cache, you have a cache that automatically imports and temporarily stores data that's being used by your compute jobs on AWS. And when your data is in the cache, your AWS compute cluster has access to that data at sub-millisecond latencies and up to hundreds of gigabytes per second of throughput. And so a bit more about what File Cache is. So at its core, it simplifies cloud bursting from on-prem file systems to AWS in the way that I just described it. And so how does it kind of work? What's the experience? Well, you spin up a cache, you link it to your on-prem file system. You then, the cache is actually a file system, exposes a file system interface, so you mount that cache from your compute cluster on AWS. And if you start LSing, you'll start seeing the directory structure from on-prem. And when you start reading files, they automatically get pulled into the cache in real time as you're accessing them. And then once they're on the cache, you're able to access them again at really high speeds, low latencies. It minimizes storage costs by automatically evicting older portions of your data set. So think of kind of a typical cache, and you really only want your hot data, and you don't want the cache to be huge. So that's a big part of what it does. As I mentioned, performance scales up to hundreds of gigabytes per second of throughput, millions of IOPS, and it's sub-millisecond latencies. And because it's an AWS service, you can deploy your caches as infrastructure as code using an API. So really easy to kind of orchestrate these spin-up, spin-down workloads. And although it's not the focus of today's talk, File Cache can also act as a cache in front of S3. And what that allows you to do is to have a high-speed file system interface that is in front of your S3 bucket, and your S3, or it could be one or more S3 buckets in multiple regions, for example. You're able to process your S3 data sets using this high-speed file interface. You're able to unify them into a single namespace. And there's 3 design goals that we had when we built File Cache. The first is fast. It's about completing your compute projects faster so that you get to results more quickly and you pay for compute for less time. So it saves you money because of its speed. Simple. Our goal is no changes for customers. So a lot of the data processing applications that customers are using, the high-performance applications, are file-based applications. And this exposes, the cache is exposed as a file system interface. So instead of directly mounting your primary data set, you mount the cache, and your application can be agnostic to the fact that there's actually this cache there, and it just works. And then finally, cost effectiveness was a big part of our design and what we built. We designed it to ensure that the cache itself is efficient in terms of how it caches data, how it utilizes storage resources. So I talked a little bit about the cache eviction, for example. It's one way that we are focused on cost effectiveness. Even though it's just a small portion of your data set and it's generally a short duration, we still know that costs matter. And so the cost effectiveness piece was a big part of it as well. So Eric's going to join me on stage now, and he's going to go through each of these in turn and give a bit more detail.
Thanks. Thanks, Ed. So why don't we go ahead and take a deeper dive right now into how File Cache accelerates data access, which ensures that you're feeding your compute jobs data as fast as they can absorb it. To give you a clearer idea of how File Cache optimizes compute, let me tell you a little bit about a case study that we're going to publish really soon as a blog post out on the website, where we use File Cache to render video in the AWS cloud. In this example, we are rendering 100 frames of video with 100 EC2 instances, and we have one application that's actually using File Cache as a data store, and one application that's actually using an on-prem filer. What we found when we ran this benchmark was that our file cache application completed the job 93% faster than the same application that was consuming data from an on-prem filer, and that resulted in about a 10x cost reduction in the workload because the compute cluster needed to run that much less time. For customers who are bursting to the cloud for compute access, they often tell us that once they move to the cloud, they start to uncover new bottlenecks in their workloads around networking or storage throughput, which ultimately lengthens their time to get to results and ultimately increases the compute costs. To achieve ideal scale, our general recommendation is data access speeds need to match your compute scale, which again reduces your time to get results and optimizes your cost performance. File cache is built as a scale-out storage solution. And what this means is that as you increase the amount of storage you provision, you increase your throughput as well. With file cache, you can provision caches up to petabyte scale with hundreds of gigabytes per second of throughput, millions of IOPS, and all of this happens with sub-millisecond latencies. No more making your compute wait for data. Next, let me tell you a little bit about how file cache makes it easy for you to take advantage of all of this speed without needing to change your workflows or applications. File cache caches source data that could be coming from S3, it could be coming from an on-prem NFS filer. For workloads that are running on-premise, you can now burst to the cloud and have that workload read data from file cache at low latencies, high throughput, without having to worry about the data being far away or in another location, and being able to sort of without having to change your application to consume that information. File cache can cache data from one or more on-premise NFS filers. What that means is you get the data, directory structures, and other properties like permissions, file metadata, as all copied over into the cache. As your application accesses that data, file cache will then on-demand load data in or lazy load data from your on-premise filer. Because the data is the same, your cloud workload doesn't need to be modified to consume that data inside a file cache. Finally, let's talk about how efficient file cache is, which minimizes your storage costs. File cache's cache management functionality lets you provision storage and only pay for what you use and what you really need. We price it at about $1.82 per terabyte hour. And one thing to note that data ingested into the cache is free for ingestion, as are the transfer and I/O costs between the EC2 instances and the cache that are running in the same AZ. Because many workloads only use a portion of the total data set, or something we would call the active working data set, file cache lets you provision a cache which will hold your active working data set, which reduces the total amount of storage you need to provision to run your cloud workload and reduces the total cost of the storage for that particular solution. File cache is a fully managed cache, which means that you provision a cache large enough to hold your active data set, and then file cache will automatically release older data in the cache when it's no longer needed, making space for new data to be then loaded in from your on-prem filers. Many customers further reduce storage costs by creating and tearing down caches as workload demands. These spin up and spin down workloads will provision a cache, connect to a filer, and they can begin processing data immediately, again, because of this loading functionality. All of this makes file cache an important part of a cost-optimized solution for compute-intensive workloads. One customer who's using file cache is Cahal Neuroscience. Cahal captures and processes hundreds of terabytes of images as part of their research to cure disease like Alzheimer's and Parkinson's. Cahal's brain imaging systems collect data at a rate that requires data to be processed as soon as it's generated, or else they see backlogs of data, which slows their research process down and increases their operational complexity. File cache provides them a fast, simple, and cost-effective way to use AWS compute with their data collected on-prem. Amazon File Cache brings the power and scale of AWS to their on-premise data. Now I'd like to bring up Brandon Lindauer, content production specialist here at AWS, to tell us more about how file cache is used in media and entertainment workloads.
Thanks, Eric. Let's talk about Visual effects. In media and entertainment, visual effects are everywhere. So they add to the action and adventure. They help you suspend disbelief with the realism. They help create unique and immersive worlds and experiences for audiences. Visual effects really are everywhere. It's hard to create a modern film, television show, or even a commercial without having extensive visual effects involved in them. I'm Brandon. I get to have one of the coolest jobs at AWS. I get to work with studios to help them adopt cloud technology and use it to make some of these really cool experiences that our customers and audiences all over the world like to see every day. I want to talk to you about something called rendering. So if you're not familiar, rendering is a process where 3D models have lights, shaders, and other elements applied to them, resulting in a finished high-resolution image. The more elements or simulations in a scene, the more compute power is needed to render that image out. And that's how we get some of these really good photorealistic images, or in this case, really nice cartoons that we like to watch. So with all that compute power that's needed to create these and create those final images, right, there's a lot of compute power there. So what do? We break up that processing. We take that processing and we distribute it across to multiple computers that are going to run simultaneously. Each of these computers will access the source files, the source content, and they'll process a little piece of that final image before they're all stitched back together. This group of computers that we distribute to, we call this a render farm. Render farms are very common in visual effects in the entertainment industry, and they're a good way to cut down your render time from days to hours or hours to minutes. So most customers have some sort of on-prem resource. They're usually small render farm near their artists, because everyone's at a different point in their cloud adoption journey. But on-prem hardware has limited scale. The massive scalability of AWS allows customers to burst their render capacity as large as they need it, sometimes to thousands of compute nodes. That increased capacity lets artists deliver content faster. And you use the most compute, usually when you have the least amount of time. You're up against a deadline. But in order for your render to happen, every node has to have access to the content, to the source content. If you go to render something, you bring 10,000 nodes online all at the same time, and they're all accessing your source storage across an internet connection, you're going to have a little bit of a bottleneck, not to mention the latency that comes with that. So when you're accessing 10,000 instances across the internet, you have limited bandwidth, you have high latency, all of this really starts to add up. And what happens is you have these render nodes that are adding compute capacity, but are bottlenecked, that are limited by what they're able to do. So what do? Well, obviously, it's really easy. You take that content and you move it to the cloud, right? Well, wrong button. A visual effects scene that we're going to render is made up of hundreds or maybe tens of thousands of elements. So between models, shaders, and simulations, there's a lot of parts that make up the whole of the image you see. It's really not feasible to copy the entirety of the data set to the cloud and to manage multiple copies when you're working on premises. It's also not really feasible to manually go in and find and copy each of those individual files and elements that make up this whole. When really what these artists and studios need to be doing is rendering out so they can continue to create. So the problems the studios are facing are, what data do we need to put in the cloud? When do we need to put it there? Where are we going to put it there when it gets there so it has the high-speed access? And how do you get it there? These are real problems that our studios, Hollywood studios, are facing every day. So Amazon File Cache takes the guesswork out of moving data. It provides a high-performance file system in the cloud, populated with only the content you need, only when it's needed. So as content is requested, those files are automatically populated in File Cache and made available to the cloud resources. Once your processing is complete, you can purge the cache or you can spin it down, reducing the cost and overhead of maintaining persistent storage. So File Cache also reduces the problem of the high latency, that bottleneck that we talked about a minute ago. The problems that you'll see in those hybrid environments, it reduces those and sometimes completely eliminates those. This allows the resources to complete their tasks faster and more efficiently, saving you time and money. So to give you an example, a studio in the United States could potentially take advantage of compute on a different continent without having to move their entire data set out there. And when it's done, it can just spin everything down, taking advantage of really a global compute resource. Or maybe, to give it a different example, you already have a global workforce. You have people that are working in the cloud all over the globe, and they are delivering to buckets all over the world. Amazon File Cache allows you to access multiple storage locations in a single unified file system presentation. So we can actually take the English version, the French version, the German version, and the Japanese version of a film and have them all delivered locally, but then present them to a single location in a unified view so that you can put them into your distribution pipeline, transcode, distribute, and send those out to theaters, to streaming platforms, and ultimately to the customers that want to see them. So whether you're rendering and you want to take advantage of the improved agility, if you're transcoding, right, and you want to have that global content pool brought to you, whether you're creating animations or consolidating and delivering your assets, Amazon File Cache makes it faster, simpler, and more cost-effective to create content in AWS. So, Eric?
Thanks, Brandon. So to wrap up, Amazon File Cache gives you a fast cache that reduces your time to get results and lowers your compute costs by reducing the amount of compute time you spend. It's simple to use. If you have an application that works with a file interface or with files, it will work with File Cache. And File Cache's automatic cache management capability gives you a cost-effective solution to reduce storage costs for burst workloads and for bringing on-prem data into the cloud. There are several other sessions that you may want to check out that are related that we kind of put up here on the slide. I would like to thank everybody for making it all the way here to the end of the hallway to attend our session this afternoon. Please remember to complete your session survey. The feedback helps us make reInvent great every year. And we're going to hang out here up at the front. If folks have questions or would like to sort of chat with some of the presenters, we'll be here for a minute. And so thanks, everybody, and have a great afternoon.